Hi, I'm Cristiano, or just Chris. I'm an engineer at REIVAX, and I will present about the SGR01 supervision system, eVision. The SGR01 is the controller of the REVAX energy speed governor applied to medium and small hydroelectric power plants. The focus here is on system operation. Then the main screens of the eVision tool will be presented. The SGR01 has 4 separate software tools: eVision Workstation, eVision Panel, eVision Remote, and eVision Simulator. The eVision Workstation is used on a computer, usually during the commissioning of the controller. eVision Panel is installed on a graphical interface located on the panel door next to the controller. eVision Remote is usually used in a remote supervision system in a control room far from where the controllers were installed. eVision Simulator allows dynamic computer simulation, being very useful in demonstrations and training. This software is protected by a hard key or dongle. The screens of the 4 softwares are similar, with small differences only. Here in this presentation I will work with the SGR01 eVision Simulator version V105 revision 001. The objective here is to present about the screens and the main functionalities, if it is necessary to obtain information on how to connect the communication cable to the module SGR01, how to replace the flash memory for a new module, or another maintenance details. Please consult the manual or access another videos in this series. So now focusing on the eVision screens, the first screen is the password screen, where different levels of access can be registered. Click here, check the passwords. Check the passwords registered in the power plant commissioning report. So I will start with a standard eVision simulator password. If we are accessing the module after turning it on, it is necessary to access the events screen and press the reset button, eliminating the trip observed at the top. Alright, this. Events, reset, yes, and now we can see the status ready this point, and we come back to main screen. So REVAX energy is configurable and can be used in different power plants with different elements. Talking about the different configurations available in the equipments, we will access the setup parameters external settings screen. Setup parameters or general settings. Here in the screen there are several options for the adjustments. We will focus only on the type of turbine here. And for simplicity, in my presentation here, we will choose a Francis turbine without the distributing valve. So this option. All other features will remain as standard for this presentation in this moment, okay? So returning now to the main screen, the main readings of the controller, the main informations are presented. Terminal voltage, stator current, active power, reactive power, power factory, frequency, Y1, 2, 3, 4. This is depend of the configuration. In this case, for a Francis without distributing valve, Y1 is the wicket gate position in percent. So on the operation screen we have the indications at the top here, the name of the screen that we are accessing right now. Then we can see here ready or not ready when we have a failure. We have here no failures or alarm in yellow and trip in red. We can see here local operation or remote operation when came commands from protocol, and if you have channel 1 or channel 2 in double operation, in a double configuration. So in this part, okay, on the right side we can see the available control modes for offline or online operation during interconnected or isolated operation through this button here, control mode. We can see here power, opening, or level and synchronous condenser. We can see here the level and synchronous condenser are disabled in this moment. Online configuration, when we can select the interconnected operation or isolated operation too. So below are the commands to start the machine and to stop the machine. Okay. In the central part of the screen, a lot of information are shown, including the set points buttons. For example, now we can see we have selected the speed control, and here we can see the place to input to write the frequency reference, for example. Let's do a simulation now. I will start the machine and observe the variable's behavior. So I will start like this. We can see some permissives to start the unit. All are okay, and yes. Now after the start command, the regulator reference went to 60 Hz. We can see like this, and we can see the opening of the wicket gates, the machine acceleration. We can see the frequency is increasing, and the stabilization in the nominal speed. Let's wait some seconds. It's possible to see that we have here nominal speed, all is okay, and now the opening is controlling to controlling 60 Hz the speed or frequency and speed the machine. So it's possible to apply a new reference value using these commands like this. I will open, so let's wait some seconds to stabilize in 60 Hz. Okay, now I can access with this button and put a new value, for example 61 Hz, and enter, apply, and we'll go. Obviously if you have a graphic interface, you can operate with your hand, is touch screen. We can see here the new reference 61 Hz, and the control loop will control like this. So let's come back to 60 Hz and apply and wait the controller works. closing a little the wicket gates to control the frequency again to 60 Hz. So, on a real machine, to connect the machine to the system, we need to excite the machine and after synchronize to the grid. Here in the eVision simulator is considered that the machine is already excited, so it's possible to close the 52 breaker using the button on the trending screen. Let's go there, trending, and we can put like this, online. So now we can see here online and come back to operation screen. We can see that the control is not in speed control anymore, but now is in active power control. We can see the wicket gate opening until a value, a preset value of power, presetted value. It's possible to define a new reference value using the commands that I will show you in some seconds. This first value, we say preset value for load condition. We can adjust for a small value like 1 or 2 or 5 or 10% of nominal load, or we can adjust after close the breaker. We will increase the power until the nominal power, for example. In this case, we have here a machine with 50 megawatts, so I adjusted the controller to send the generation until in the middle, 25 megawatts. So we can see here the reference. So during the operation of this the loop control, we can change this active power reference to another value. For example, 30 Hertz, 30 megawatts, and apply. We can see here the reference is increasing smoothly until 30, and then the control loop will increase until arrive to this value. So okay, now talking about the control modes, usually the unit works in active power control all the time. However, in some cases it may be necessary to switch to opening control mode, or level control mode, or synchronous condenser control mode, like we can see here. Power, opening, level, and synchronous condenser. So now if we access this control mode and do like this opening, we will change to opening controls. So we can see basically that the operation point is exactly the same that we was in active power control. Now we have opening control. So this opening control is usually necessary when we are testing the machine during the commissioning, or when we have a failure with the CTs or PTs. So I will come back to power control and we can see this. So remembering that in case of any failure in the measurement of PTs or CTs, I talked, the governor will automatically switch from power control mode to opening control, bumpless, maintain the same operating point. So switching to the to another screen, we can see here another informations like electrical protection, mechanical protection, start permissive, another monitoring points. So then this is basically what we need to know about this operation screen. Now we can see here in events screen, it's possible to see the active alarms. Obviously now we don't have nothing. And the failures alarms will be presented in yellow, and the trips this will stop the machine in red, obviously. So when we enable the SOI sequence of events, another window will appear here, and we can see the list of events in this way. So the trending screen allows us to see and save the main monitored signal. This is the oscillography. To start the monitoring, we can click here in this part, and when we click stop, we can save these signals through this button here. So we will save here in my computer, for example, and we can open with another software called SVC, software visualization curves, or curve visualization software, which this SVC software is free for all REIVAX customers. Okay, the testing screen presents testing tools for hardware, as well the available control loops, including tools for adjustments. This topic will not be detailed in this video, but will be detailed in another video. Okay, the setup screens shows in addition to general settings that we saw, which are the equipment settings, references, start and stop parameters, load taking, etc. This item will also not be detailed in this video, but in a future opportunity. To exit the screen blocked for improper use, click the button in this lower right corner like this and click logout. Okay, thank you. I see you in the next video.